Welcome to The Explainer. Today we're diving into two absolute superstar nutrients. I mean, they're essential for life itself, but get the balance wrong and they can be dangerously toxic. So, let's start with a question. What could life-giving blood and, destructive rust possibly have in common? The answer gets to the heart of the surprising dual nature of a single powerful element that's running through your veins right now. And yeah, the answer is iron. This is the story of iron and folate, and the incredible, really invisible systems your body uses every single second to manage these powerful double-edged swords. Let's kick things off with iron. Your body needs it for pretty much everything, from making energy to carrying oxygen. But if it's just left to roam free, it acts like a poison, literally ripping your cells apart. Okay, so to understand how your body tames iron, you've got to know it exists in two states. On the left, you've got the ferrous form. That's the one that's super reactive and dangerous. And on the right, the ferric form, which is stable and safe. Your body's entire strategy, it revolves around keeping that dangerous form under lock and key. So check out this incredibly clever four-step process for absorbing iron. First, in your gut, the safe iron you get from food gets converted into that dangerous reactive form. Now, why would it do that? Well, because only that form can be pulled into your intestinal cells. That's step two. But the second it's inside, a decision has to be made, and fast. Either you store it safely right there in the cell, or in step 4, you export it into the bloodstream to be used somewhere else. The whole system is just built around minimizing risk at every single turn. And if that iron does get exported into the blood, it can't just wander around on its own. No way. It's immediately picked up by its dedicated taxi service, a protein called transferrin. You can think of it like an armored car, making absolutely sure its dangerous passenger gets to its destination without causing any chaos along the way. And what about long-term storage? Well, for that, iron is locked away inside your cells in this secure protein bunker called ferritin. This not only stops it from causing trouble, but it also creates a vital reserve your body can tap into whenever it needs it. But hang on, how does your body even know when it has enough iron? How does it control this whole complex system? The answer is a master regulator, a hormone that your liver makes called hepcidin. It's basically the air traffic controller for your body's entire iron supply. And this is how it works. It's actually brilliant. When your iron levels get high, your liver sends out hepcidin. Hepcidin travels to your intestinal cells and it essentially locks the exit doors. That's the ferroportin protein we just talked about. This traps the iron safely inside those cells, which stops your body from absorbing too much. It's just a simple, really elegant feedback loop. So we've got this amazingly well-controlled system for iron, which is a key building block for our red blood cells. But what about the blueprints needed to build those cells in the first place? Well, that brings us to our second nutrient, folate. If iron is the critical building block, you can think of folate as the master architect. Or maybe a better analogy is a biological photocopier. Its main job is to help build and repair DNA, which, is the blueprint for every single new cell in your body. Without enough folate, you just can't create new cells properly. Now, this is what folate looks like on a molecular level. You can see it's built from these three main parts. But in this exact form, the kind we get from foods like leafy greens, our body can't actually use it. It's kind of like a key that hasn't been cut yet. It needs to be processed, converted into its active form before it can unlock anything. And this right here is the chemical assembly line that does that conversion. Now, don't worry about memorizing all the details. The key thing to see is how that initial molecule gets changed, step by step. The most important worker on this entire line is an enzyme called DHFR. It performs the final, critical conversion, creating the active form, THF. That's the molecule that actually gets to work building our DNA. So why does all this matter so much? Well, because low folate levels in early pregnancy are thought to be the cause of more than half of all neural tube defects. We're talking about conditions like spina bifida, where the spinal column doesn't form completely. That's just how critical this one vitamin is to building a new human being correctly. Okay, so now that we've seen these incredibly intricate systems for managing iron and folate, let's take a look at what happens when that delicate balance is lost. When it comes to iron, that balance is just so critical. Too little and you get anemia, which leaves you feeling fatigued and weak. But too much, a condition called hemochromatosis, causes that excess iron to literally build up like rust in your organs, poisoning them from the inside out. Now,
A lack of folate also causes anemia, but it's a totally different kind called megaloblastic anemia. It happens because that DNA photocopier we talked about is essentially broken. So the bone marrow ends up producing these giant, immature, and pretty much useless red blood cells that just can't do their job properly.
This table really just lays it all out, doesn't it? It's such a clear illustration of that double-edged sword we mentioned at the beginning. For both of these nutrients, iron and folate, straying too far from that perfect sweet spot in either direction has really serious consequences for your health.
And the stakes are particularly high for iron because of this one crucial fact. Unlike most other things, your body has no real way to get rid of excess iron. The only way out is through blood loss. It's thought that way back in our evolutionary past, blood loss from injuries was pretty common, and iron in our diet was scarce, so our bodies evolved to just hold on to it at all costs. This makes that elegant hepcidin system we saw, the one that regulates intake, not just important, but, well, everything.
So what we've really seen today is this hidden world of just incredible precision. From taming a toxic element like iron to photocopying the very blueprint of life with folate, your body is constantly performing this high-stakes balancing act. And it's all happening silently, completely beneath our awareness. And that really just leaves us with a final thought. When you reflect on this one intricate system, it really makes you wonder what other invisible, perfectly tuned miracles are happening inside of you right now just to keep you alive.